working through physics problems. This is OpenStax, Chapter 3, number 25. Okay, so the problem says a ball is launched from the ground with an initial velocity of 50 meters per second at an angle of 30 degrees, and it's in the air for 3 seconds. What is the x and y position of where it lands? It doesn't say it lands on the ground, right? Actually, it technically says strikes a target above the ground. Okay. 3 seconds later. And this is a little different because normally we don't have the time, but we have the time. So let's just go ahead and remember in projectile motion, we can break the motion into an x and a y components. So the first thing I'm going to do is to find the x and y initial velocities. So if this is my velocity v0, and that's the angle theta, this is my x velocity, and this is my initial y velocity. Why do I put an initial for the y and not for the x? Because the acceleration in the x direction is 0. So it doesn't change. The initial is the final. It never changes. But here, the velocity does change in the y direction, so I do need to put that down like that. Okay, so if I know those values, I can find Vx. It's going to be the initial velocity times cosine of the angle theta, because it's the adjacent side of the triangle, right? Cosine is adjacent over hypotenuse. And Vy0 is V0 times sine of theta. And so I can get values for this. Let's just go ahead and do that. This is going to be 50 meters per second times the cosine of 30. And this is going to be equal to 50 meters per second times the sine of 30. I like to do things, put my numbers in at the end usually, but just for fun, let's just put it in our calculator. Okay, so I have 50, 30 cosine times. So this is 43.3 and then I have 50 into 30 sine times, and this is 25. I knew that. So those are my two velocities. Let's just go ahead and put them over here. Vx equals 43.3. Vy0 is 25 meters per second. Now we can break this into x and y motions, and I know the x velocity, I know the y velocity, I want to find the final x position. Let's just say the initial x position, x0 is 0, y0 is 0. It doesn't really matter because we're really trying to find the change, but they said, where does it land? So let's do that. So let's do the x direction first. In the x direction, the acceleration is 0. So I have this, x0 plus vxt. That's technically 0, but it doesn't really matter. I know x0 is 0. I just calculated vx0. I know the time of 3 seconds. So I'm done. X is 0 plus 43.3 times 3. 43.3 enter 3 times 129.9. Okay, that's its final x position. Now let's do the y. Y is y0 plus vy0 t minus 1/2 g t squared. That's what we have for constant acceleration, and the acceleration in this case is negative g, where g is 9.8 meters per second squared. Well, I know everything here. Let's just plug it in. So y, is that too low? Nope. Y is 0 plus 25 times 3 minus 1/2 9.8 times 3 squared. And we get, I'll put it right here, calculator, drop, 25, 3 times 0.5 negative, enter, 9.8 times, and then 3 squared is 9 times, plus. I get 30.9. So my final position, if If you want to write it like this, you can. It's 129.9, 30.9 meters. And then it's always fun to put a box around it because it just says, hey, I'm done, I boxed it. And that's that. The end.